So I just wanted to talk about the digital supply chain, what we're seeing. And I think if you were at the keynote, you heard some people saying that the term digital or digitalization was a buzzword. And I kind of agree with that. But what the gentleman from Dow Chemical said today was interesting. He said, you know, when I look at it, right, the first time somebody put in SAP 30 years ago or more, they went from paper-based systems to software. To me, software is digital, right? But what he was saying was, we all have all this data that we've collected, and we're using such a small percentage of it. So for them, digital is being able to more fully use all that information they have. Clearly, machine learning, clearly artificial intelligence will be part of that. But when I think about digital, I'm also thinking in terms of emerging technologies. So I think it's this one. We put together a supply chain maturity curve for some of these technologies. AMR up there stands for autonomous mobile robots. In our next session, which is what we have at the top of the curve, we have some vendors in here that are going to talk about robots, autonomous robots being used in the warehouse. Very good session. Hope you stick around.
It's good stuff. We like them.
Good. At the very bottom, we have blockchain. Now that's my opinion. I don't think blockchain is mature yet for supply chain applications. Tomorrow we've got a panel of experts, and they may prove that I'm absolutely wrong. So if you're interested in blockchain, that's tomorrow morning at 10. But then we have all those other technologies. So right in the middle, we have SNU, social news, event, and weather. Maybe that's more mature than I thought. So I would classify risk methods as a SNU application using real-time data to better deal with your supply chain risks. Maybe we have that too low. But first, let's start with autonomous trucks. I think that's kind of low on the maturity spectrum. When you look at this levels of automation, the automation hierarchy, it looks fairly linear. But actually going from one level to another is, it's a magnitude more difficult in the sensing technology needed, in the computer power, in the communication infrastructure. I don't know if any of you have been going to the smart cities tracks. I've been doing it just because I think they have a lot to say about what logistics is going to be in the future. One of the participants was talking about that, you know, when there's an NFL football game, and I can't remember how many terabytes of data is used around, you know, NBC or Fox or whoever is doing the game, but tremendous amount of terabytes. And what this gentleman said is, we're going to need double that amount of terabytes just communicating between a smart city and individual cars. We're going to have to get to not just 5G networks, we may have to go a generation beyond that. And what they're talking about is the car has to be, we sort of think the car can see and make sense of what it sees. That is a much, much more difficult problem than you think. And from a smart city point of view, they want to be able to communicate that there's this many lanes, the lanes are this wide, there's a shoulder, but the shoulder you really can't use it, it's too rough unless, boy, it's a total emergency. There's raised ground in the middle, so if you try and, you know, navigate up there, you're going to have a crash. There's a traffic light coming up. We got to communicate that it's going to be green for you or it's going to be yellow. It's, so tremendous, not only machine learning advances have to be made in terms of vision recognition, but just the communication infrastructure to get all of this working is still massive. So it may be 20, 30 years before we get to that full vision of full autonomous driving in an urban area. That said, there may be value in just going from one level to the next. So one of the things that we're talking about in logistics right now is truck platooning, where you'll have a convoy of trucks, there'll be a truck in front, all these trucks will be following, basically tailgating. When the truck in front speeds up, every truck in the convoy automatically speeds up the same amount. When it taps its brakes, everyone else in that convoy brakes to the same degree. And the value of this will be fuel savings. So cool idea, maybe only a year or two away from being real. It's it's not full autonomy, but it's progress. The problem is, when I think about this, how many supply chains actually have the need for platoons of trucks going from, for example, Dubuque, Iowa to Chicago, right? If you talk about the fracking fields and sending trucks and trucks full of sand to an oil field, well, that might make sense. I think for most supply chains, it's going to be hard to get value from this. And we haven't figured out on an ad hoc basis how trucks from different companies will be able to join a platoon and make that work. So interesting idea. I think we're making progress. I think it's still pretty early maturity stuff. The other thing we're starting to talk about in logistics is the Uberization of freight. So Uber transformed the taxi industry. It understands where all the taxis are. It understands where people are that are asking for these, we'll call them taxis. It does good logistics optimization around that. They're doing surge pricing. They're doing a lot of really smart supply chain optimization. So can we apply this to the supply chain? Well, we can. I'm just not sure how much value we get from it. And there are already some Uber apps that are starting to apply some of these concepts. Uber Freight exists. But the truth is, large shippers look at their network, they look at what they're going to ship in the coming year, where they put contracts out to bid to the big 3PLs, and they commit most of their freight, and they get better savings and they get better service by making these 1 or 2 or 3 year commitments. So when we talk about the Uberization of freight, I think there is a play in the spot market. There's a play for small manufacturers that don't generate big volumes, but most of that freight is still going to go contract. Social news, event, and weather, blown away by what AGCO did with risk methods. General Motors has done the same thing with the competitor risk methods. And a lot of what you hear a lot of times is companies have some big disaster. They get spanked real hard because they didn't do risk management well. And they've learned the hard way they need to do it. So we can map our supply chains. We can use social media and news. We can listen for what's out there. A company called JDA, which is a supply chain software company, is working real hard also to incorporate sort of predictive analytics on, if a truck is going from Los Angeles to Chicago, we know there's a snowstorm in Kansas City, route around that. And so the idea is, how do you update your transportation management solution on an ongoing basis using predictive analytics from SNU? And it's actually, many TMS companies will not be able to do it, because if you've got 1,000 tenders out there and you've got a prediction that something needs to be changed, you don't want to have to undo 1,000 of these loads. So what you want is somehow to be able to snake in there and preserve optimization while only changing some of those loads. which is a difficult thing to do. But anyway, there are companies that are really thinking about how do you do ongoing supply chain planning using predictive analytics while preserving the optimization that's going on. 3D printing, interesting idea. Really, from a supply chain point of view, potentially very applicable from reducing spare parts in warehouses around the world. There have been some problems, right? First of all, a company has to have specs on old, for example, tractors. You may have tractors that have been out there 20 years. And does AGCO still have the specs for that? The other thing that you start to run into around 3D printing is you may produce a very good part from 3D printing, but the lifespan of that, the performance of that may be very good, but it's going to be different than if it was produced on traditional machines. So there have been culture wars. There have been fights between logistics and manufacturing about that issue. And it's brought some companies' 3D printing programs to a grinding halt. And yet, in some cases, if you think about it, right, we may get to a point where we have to ask, what's good enough, right? So if a farmer needs a part to keep his $1 million tractor going, and that part is not as good as produced in a traditional way, he still wants that tractor going. So maybe we get to a point where we produce a 3D part, we know its specs aren't quite the same, we get it in the tractor, you run it for a while, we produce the part in traditional ways, and we give the farmer an option to sort of take that traditional part and replace the 3D part if they want. So I think that's the kind of thinking we're going to have to start thinking around. And then there's issues of centralization when it comes to 3D printing. So, if we've got remote warehouses, if we've got third-party logistics companies running our remote warehouses, and we want them to produce parts, we want to make sure that we guarantee that they're using the materials we've specified, that if we're asking them to print 5, they only print 5, that nothing ends up in the gray market. So there has to be a level of control and management around this to make many companies happy. We have, I think there are good solutions for centralized control and management of 3D printing, but we are still fighting the cultural wars around this. Machine learning, predictive analytics, we're talking about it as if it's new. In the supply chain, it is not at all new. So when it comes to demand forecasting, we've been doing versions of machine learning for about 20 years. So the way it works in forecasting is there's different math applied to different types of demand patterns. So a new product introduction has a certain kind of math applied to it. Steady state demand has another type of algorithm applied to it. A part reaching end of life has another algorithm that works best. If we're having a promotion, it may be one of 2 or 3 algorithms that work best. And so the way demand forecasting has worked is the forecast is produced using a particular algorithm, and then we have history on how good that forecast was. And you use that history to say, I think we've moved from algorithm 3 to algorithm 4. Mr. Demand Forecaster, do you want to apply it? So the nice thing about machine learning and demand forecasting is this is all one system. It's easy to get that data you need to get that iterative learning process. Where supply chain planning has fallen down is using machine learning to improve supply planning. And that's because To do supply planning well, you need stuff from manufacturer execution, you need stuff from the quality systems, you need it from a variety of systems, including planning. And getting that learning loop when you're dealing with integration, I think is probably what has slowed us up on applying machine learning to supply planning. Autonomous mobile robots, I'm not going to say much about them, except, boy, stick around. Boy, we've got a great show, a great session coming up next with some of the robot guys. And that is all I had around my look at what we'll call smart logistics technologies, smart supply chain, digital supply chain, new technologies. But any questions, comments, disagreements on where I put these solutions on the maturity curve, I'm open to hearing.
Maybe one question which also relates to you, Greg, is you talked about the autonomous trucks. Where are we with autonomous tractors?
It's been in the market since 1990,
Yeah.
and we've got, in the fleet or in the farms now, no problem.
So they are leading the way in that perspective as well.
But it's less complicated than what we have within the network, because we had a long discussion with the lead guy for Toyota last year in Bahrain and he's in charge of like Toyota's 2040 strategy. And the challenges that Steve talked about is the network upon network upon network that has to be integrated, and then across the different OEM providers, open architecture, because all of these machines, whether it's an auto, a truck, or whatever, they all have to talk together with the cities, together with the network. So there's a lot of complexity on the road versus what there is in the field.
Because the field is empty. You don't share it with another tractor.
Well, you still have the challenges in terms of safety and the sensorability and things like that you've got to take into account, but it's much less complicated than on the road from a just pure numbers perspective. Yeah.
And are there advantages to having autonomous tractors? Do you get better yields if you do that?
Well, it allows the precision to be much tighter, and you can get down to 3 millimeters in terms of precision that you want to have. So in terms of the machine hours that you're running, the cost per hour is a major factor for our customers. So if you're driving at less hours, you're more efficient.
Well, and I would think if you're down to 3 millimeters, if you're doing it manually, you go down a row and you turn and you probably overlap and you probably have places where you don't drop fertilizer or seeds, and I would think just the precision would be a good thing.
Well, that's an entirely different set of, let's call it, technology that's in terms of the application
Right.
of what you put where within the field.
Right.
But from the autonomous driving, it's more just the precision on your lanes,
Uh-huh.
and then the efficiencies and the wear and tear that you've got on your machine.
Okay.
Same on the same question, you talk about conversation. You see about plowing as a service, don't sell tractors.
It's huge in the market, been there for years, particularly on the sprayers, on the combines, the balers. Yeah, that's been in the ag business for a long time. It's one of those things that sometimes you don't want your customers to have to use if their machine goes down. But they're out there.
Well, gentlemen, it looks like that may be the questions. I'd like to thank you very much for coming, and I'd like to give Greg another round of applause. What they're doing is fabulous.